All right, so building off of our definition for work, we can start to talk about the potential energy. So we know in general, the work done by some force F on an object as it moves from an initial point to a final point is given by the following. So this is the most general expression. So here F can vary. Again, we're going to take the dot product of that force with our tiny little infinitesimal displacement, and then we're going to add that up as we go from some initial position to some final position. If we have a conservative force, and we'll talk a bit more in a minute about what makes a force a conservative force, then we can relate the work done by the object as it moves from some initial position to some final position to the change in the potential energy of the system. So basically the change in the potential energy of the system, so we're going to use U to mean potential energy, is equal to negative the work done by our conservative force. So again, the C subscript here is telling us that we're dealing with a conservative force. So this is the work done by the conservative force. So again, just plugging in our definition for work, this is just negative the integral from some initial position to some final position of the dot product of that force in with our tiny infinitesimal displacements going from here to here. So what does this mean? Well, sort of fundamentally, what the potential energy is trying to describe is the potential for certain types of forces to do work on an object. So again, this is only going to be for conservative forces. And by increasing the potential energy, basically what you're doing is you're increasing the opportunity for a force to do work. So one of the forces that we will talk about in terms of potential energy is the gravitational potential energy. And the higher you lift something up, the more potential exists for the gravitational force to do work on that object. So basically, the higher you lift something, the more work gravitational force can do on it once you let it go. So that's what the potential energy is trying to measure. So what is it that makes a force a conservative force? Well, there are a couple mathematical definitions for them. And one of them is if basically you start at some point and you move wherever you want to, and you end up coming back where you started. So that defines what's known as a closed path. And if you calculate the total work done by your force on your object as you move it around that closed path, if that total work is zero, then you have a conservative force. So as an example, let's say I took a box, and so for this first picture, let's assume that we're looking at this box from the side, and so I'm lifting it up gravitationally, right, or lifting it up so that gravity can act on it. And so if I let the box fall, well, I know gravity will do some positive work. And then if I move it to the side, well, there's no work done there. When I lift it back up, gravity will do negative work on it now. And then when I slide it back over again, because it's staying at the same height, no work's done by gravity. So I have a closed path here, right? I ended up back where I started. And when I add up the work done over all four of these legs, I get plus mg delta h plus 0 minus mg delta h plus 0, and all four of those add up to be 0. So what this tells me is that since the work done by gravity over that closed path is equal to 0, then the gravitational force must be a conservative force. So it doesn't matter, right? There's nothing special about the path I happen to choose here. We could have just gone straight down and straight back up. We could have gone up first and then down. We could have moved in funky ways. It doesn't really matter. The important thing is that the work done by gravity will be 0 over any closed path. So that's one way that we can talk about what a conservative force is just thinking about the work done as you start from some point, move wherever you want to, finish where you start. Another way that we can define, so if we look at a second force. So let's now think of, so we're looking bird's eye view down on a box, and I'm going to move it around on some surface, and I want to think about the work done by friction. Well, again, if I move it around my surface, and I'll again move it in that same rectangle, I can calculate the work done by friction, and on all 4 of these legs, I get that the friction force, or the work done by friction, is going to be equal to, well, the friction force, mu sub k mg, because we're just going to assume that I'm pushing it horizontally, so I'm not increasing the normal or decreasing the normal by the way that I push. So the normal is just going to be equal to the weight in this case. So mu sub k times the normal, that's going to give me the friction force. I'm moving it some distance, and the displacement and the force point in opposite directions, so that's where the minus sign comes in. So here's the work done by friction, and all that changes is that, well, this distance I've happened to call little d. So here I've got minus mu sub k mg little d. Here is minus mu sub k mg little d, because I'm moving that same little d. This distance is just big D, but in all these, the work done by friction is negative. So clearly, when you add up the work done by friction over that same closed path, you see that that work, total work, is not equal to 0. So friction is not a conservative force. Another way that we can talk about what a conservative force is we can basically say, well, the work done by a force on an object as it moves between 2 points, if that work only depends on the endpoints and not the path taken, then again you have a conservative force. So if I go from point A to point B, and it doesn't matter how I go from point A to point B, the work is going to always end up being the same, then again that's a conservative force. So again, as an example, if I take my box and just move it from, again, say gravitationally from some initial height to some final height, gravity will have done some work. Well, if I started at the same height and do something funky, so move it up and down and around and da-da-da-da-da, but end up at the same final height, the work done by gravity over both of those paths will be the same. It doesn't care about all the funky business I did swinging around in this case. It just cares about, well, you started up here, you finished down there. So it only cares about the endpoints. So there are 2 conservative forces that we will deal with in this class. And I realize I put Physics 299 rather than 298. But for this class, Physics 298, there's only 2 conservative forces that we're going to deal with. The first one's the gravitational force. The second one is the spring or elastic force. Gravitational force we've already talked about. The spring force, well, we've talked about it in terms of setting up the work done by a spring. And part of why we care about the work done by a spring is that that's also going to be a conservative force. So we can talk about both of these in terms of a potential energy. So there's a gravitational potential energy, and then there's an elastic potential energy. All right, so again, here's my definition for the change in the potential energy. And so what the potential energy is trying to tell me is it's defined in terms of how the energy changes as you move between 2 points due to the work done by a conservative force. How can we determine whether or not the potential energy is increasing or decreasing? So basically, is there a way that we can think about when delta U will be positive, when delta U will be negative? Well, basically, if the object moves in the way that the conservative force wants it to go, that means that the conservative force is doing positive work, right? The force and displacement point in the same direction, so the conservative force is doing positive work. And if the conservative force is positive, if the work done by the conservative force is positive, this minus sign tells us that that means that the change in the potential energy will be negative, which means that the potential energy will decrease. So whenever your conservative force does positive work, that means the potential energy is decreasing. So to increase the potential energy, you have to do positive work against the conservative force. So part of what this means is when you do positive work that forces the conservative force to do negative work. So i.e. when you lift an object, right? We said the gravity is a conservative force. So when I lift something up, I do positive work to lift that object up. Gravity does negative work because the force points down, the displacement points up. So gravity is doing negative work which means that negative work done by the conservative force is basically being stored as potential energy. So you can get that energy back once you let the object go and let the conservative force now do positive work to move the object in the direction that the conservative force wants to. So when your object moves in the opposite of the direction that the conservative force wants it to go, then the potential energy increases.